what we're doing here is, first of all, we're going to create this 2D infinite, what I call the 2D infinite plane. And that's a place where you actually compress multidimensional dimension systems into 2D. And then that gives it, and then in order to do that, we're going to use a tokenizer to find knowledge. And that tokenizer will be probably most likely the GB2 tokenizer. And it has about 50,000 plus, tokens in it that you can use to find knowledge. And so what we want to first do is be able to mathematically represent that. And so that it would be your base number would be like 50,000. So plus. So what you're going to do here is, so we've been working on this algorithm. On working with these base systems. So think about it a little bit differently. Think you have a number one. So you have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you keep going 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It keeps going on. And what you want to do, let's just think of it like this, that you want to not count 5. Anything that has a 5. All right. So we're going to start off here this way. So you try to tackle the easiest problem you can. This is an easy problem. So this is going to, how's it going to go? It's going to go 0, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, skip 15, 16, 17, 18, 19, 20. And so the numbers you're going to be skipping, we'll just look at the number you're going to be skipping. You're going to skip 5. You're going to skip 15. You're going to skip 25. Anything that has a 5 in it. You're going to skip 35. You're going to skip 45. And then what's going to happen here is when you get to 50, you're going to skip 50, right? Because it's got a 5 in it. But now you're going to skip 51, 52, 53, 54, 55, 56, 57, 58, 59. You know what I'm saying? You're going to skip all the way to 59. See that? And then you'll skip 65. Excuse me, 65, 75, 85, 95, right? And you'll be back at 100, right? And so the next thing next number you'll skip is 105. Okay. So basically, this actually, just looking at it this way, it becomes an extremely simple problem. So all you do is write a Python program, right? That skips anything with 5 in it. All right, good. All right, so now we got, okay, all right, this is a way to think about it. And so what's interesting too is this kind of exponentiates if you look at it just for a moment. I mean, and I'll pick out a few numbers. For example, you got 50, right? And then you skip everything in that range. And then you got 500 and you skip everything in that range. And then you got 5,000 and you skip everything in that range. There are also numbers in between that you skip, but you can see these dead zones kind of grow exponentially. So I just wanted to show that to you. But they also repeat this same pattern in here over and over again. And that's also something within itself. So we won't go there today yet, but I just want to show you that. So, but basically just by using, say, skip 5, wherever 5 is in your Python program, you have just conquered it. That's your algorithm. That's what's going to go into your algorithm. That's it. All right, so that works for 5, right? So what if we want to go back to base counting? All right, let's do it for base counting. What if we do base 5? What kind of algorithm would we use there? But we're about to get it. We're almost there. This is actually fairly easy. So now let's go to base 5. And so what do you mean? So it means base 5. So if you look at base 5, then basically 5 to 9. So what you do is you skip all numbers 5 to 9. That's all you need in your algorithm. So if you look at any number that has anything from 5 to 9 in it, you skip it. That works. That is your base. So let's take a look at it, see if that's true. So you go 0, 1, 2, 3, 4. Then you skip 5, right? So what would you skip? You would skip 5, 6, 5 through
7.
5, yeah, 5 through 9, right? And then you do, so it's 5 through 9, and then you get 10, right? So you got 10, 11, 12, 13, 14. Then you'd skip what? 15 to what? 99, right? And then you're going to go to the next one, 6. So you start off with 100, right? And then you go all the way up to 104, right? You go to that, so that you would skip 105.
But Dr. Kindly, why are we skipping 5 to 9? But in the series, we have got 6, 7, 8, 9 in the series. Once we generated the first series.
Because you're doing base 5.
Oh yeah, sorry. We're doing base 5. Oh, I thought the question was yeah.
Yeah,
Fine, that's
look
good.
at base 5. Yeah, look at base 5. So basically, you're looking at what you're skipping. So here you go, and you kind of repeat this pattern. So 105 to 99, something like that, right? It also becomes a very practical problem because really all you say is you skip, right? Everything. So basically, you look at the base to 9, right? That's it. You skip everything base to 9. That's the algorithm. So whatever you choose your base to be, and this is below. We haven't gone above yet, okay? So we're gonna go above here in a moment, but that's below, okay? So there, anything you skip anything base to 9. That's it. That's all there is to it. All right. So if your base is if your base is 2, for example, we're gonna go with base 2, right? Then you would go. Let's look at base 2. This one we understand well, right? You would skip. Your skipping rule would be 2 to 9, right? 2 9. And so basically you start counting, you go 0, 1, skip, 10, 11, right? 10, 11, skip, right? Because it can't have any other numbers in it. So you're still counting. And so you count, okay, next will be 100, right? And then you skip, oh, you got 101, then you got, 1, and 11. So you're just skipping. So you're counting. So all these numbers in between, all the numbers in between, but you're skipping because you skipped 2 9. And that's it. That's all you need for your program. Now there's more you can do with this, but we're just going to hang out there. So now let's do base 14. So now that you've looked at what I've given you, what do you think the skipping rule will be for base 14?
I
And
think we
like
will
it would
have from
be
0 to 9. Sorry, 0 to 13.
0 to 14.
No, 0 to 13.
0
I
to
think
13, yeah.
So the
And
skip, go ahead, give me the skip. What is it? 14 to what?
14 to 99.
Absolutely. Got it.
yeah.
There you go. 49.9. So what you're doing in this particular case, and it makes it now very easy, because you're grouping your numbers in sets of 2, right? So because that's your construct. Your construct is you group them in sets of 2. Why? So you can actually go up to 14, right? Without having to create some crazy, alphabetical like A, B, C, D, E, F, like we do with hexadecimal, right? So you're doing that. And so what you do is for each one of these, if you see anything that's 0 to 99 in any of these columns, anywhere, you skip it. That's the algorithm. And that beautifully simple. So let's try another one. I like going up to bases. So what if I choose base 256? What is the construct for base 256?
0 to 255.
Well, let's not choose. Let's say, let me say up to base 66. Let's say up to. Let's say I'm gonna choose a base between 100 to 256. Okay. What's the construct? So here's the construct. All right, see that? What's the construct if I'm going to go from 100, for example, to 256 or beyond?
0000000.
The construct is 0, 0, 0. I need 3 zeros, right? That's the construct. See, then this is held in the programming. I need sets of 3 zeros. And the reason I need 3 zeros is because, why? Because this base needs to be, because of the base. So the construct is equal to the length of the base. All right. So now let's say let's do base. So I can go up to base 99. Let's say 999, right? So now let's do my thing. I choose base 256. All right. So what is the skip rule for base 266?
I think we will skip from 257 to 999.
You will skip from the base. That's the base though, remember? Base to 14. So basically
Yes.
what you'll skip from, you almost got it. Base,
257.
base, you go 256, keep the base to right, 999. That's your skip. So
Okay.
anything,
Yes.
it's always the base, right? Because you skip 256 to 199. Okay, got it. Okay, cool.
Yeah.
All right, that's the skip. Now, why is this important to us? Now, why is this important? So this is where it comes in. It's important here because your tokenizer has a base. It has so many items in it. Now, that tokenizer has, I'm trying to remember the number. Did anyone watch the video and watch the number? I think it's 56,276. I'll get the right number, but we'll just start with that one, okay? It may be 52 or 56. I can't remember at this point. That's how many tokens you have in the GP2 system. So the idea here is you want to actually create a construct for this. So guys, how many decimal places? I'm assuming how many places do I have in my construct? Looking at that, that's going to, your base is going to be 56,276. How many places do I need in my construct?
I have to put 5 zeros and then 5 zero ones.
Absolutely,
And then
absolutely. That's your construct right there. 5 zeros, right? Right. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5.
I don't understand this 5 zeros. Why 5 zeros?
Because your base is 5 places long. See?
Okay, sir.
So it's always a length of your base. So if you want to do base 256, then you're gonna have 3 zero construct. If you're gonna do a base of 5 units, you're gonna have a 5-unit construct. Okay. And this buys you a whole lot because when you send this back into the detokenizer, it takes these 5 places, okay, and it consumes them. Okay. Now we may have to do a little bit more work here once we start working with the detokenizer a little bit more, but that's where we're going to be, right? So this is good for the construct. And so what's the skip for this? I would program.
we have to skip 5, 6, 2, 7, 6, 2, and
7, 7,
9,
6.
9, 9, 9.
Absolutely. Absolutely got it. You nailed it. That's all you need. So any numbers, let's see, it's at 5 of them, 1, 2, 3, 4, 5. Any numbers within that range will be skipped. All right. All right. Good. You know your skip zones. So you can apply this in Python, okay? In Python. So we're actually going to, at this point, start working with the code, okay? So tomorrow we're going to start coding. Because now we have the framework. So that's all you need. Now, are there better ways to do this? Yes. And another thing too that kind of falls out of this is that even though you're skipping those numbers, you still may be using them in your calculations. Isn't that weird? And that's really bizarre. And that's the bizarre thing that comes out of here. And you'll like this, Usama, because you mentioned the human intelligence, is that suddenly you have a system that there's numbers that you skip, but that you might be using in calculations. And what's so bizarre about that is that you have an unconscious mind, right? And it's funny because I have the conscious mind. That's what I see. That's what I'm not skipping. But there's an unconscious part that's working away, that is being fed into my conscious mind. So it's almost like the unconscious mind falls out of this idea of skipping decimal places. So it's really bizarre. So I've got to run to my workout class. I think that's enough to get you guys going. What I want you to do is let's see if we can find the other hackathon that I worked on. So you guys can actually get a little bit of work on that one and take a look at that one as well. Because and look at the code on that one and see if you can build the 2D infinite plane. So take a look. And so we'll start building the 2D infinite plane. Now, let me give you an example. What I want you guys to do. I call it infinite because it could be infinite. It's really not, but it's really large, astronomically large. And so, and this is what you're going to be searching. This is going to be your bread and butter. This is where you're going to find knowledge. You're not going to be creating knowledge. You're going to be finding knowledge. And then you'll be able. And the next thing, once we build that, we got the code working. Then we'll build crawlers. Okay, that will be next thing. And that's going to be where your bread and butter is. That's where you're going to actually make this thing actually come alive. All right. With that said, because we're going to crawl that plane, and you can put as many crawlers on as you want. And we'll figure out the mathematics for that as well.